is Algebra 2, Lesson 66. We're going to talk about the signs of fractions and 30, 60, and 90-degree triangles. Every fraction has three signs. If one of the signs isn't written, it's understood to be a plus sign. So negative 3/4 is the same as negative positive 3 over positive 4, which equals positive negative 3 over positive 4, which equals positive 3 over negative 4, which equals negative 3 over negative 4. The ability to change signs without changing the value is very useful. So here's our first example. 1 over x minus 3 minus 7a over negative x plus 3. Now this is the opposite of this. So if instead of having minus 7a over minus x plus 3, we change this to plus 7a, and then we're going to change the signs down here, x minus 3. So we've moved the negative from here, we've changed this sign and changed this sign. So the value of this is still the value of this. And now we can subtract. This is 1 over x minus 3, plus 7a over x minus 3, which is the same as 1 plus 7a over x minus 3. Okay? Because negative 7a over negative x plus 3 is the same as 7a over x minus 3. This was here. We just multiplied this negative 1 through here. Okay, let's try it down here. We have 4x plus 5 over x minus 3 plus 2x minus 3 over 3 minus x. So we have a plus sign here right now, and this is the backwards of this. So if we change this to a negative and then multiply the negative 1 through here, then we've got a negative times a negative, which will bring us back to the positive. So the value of this will be unchanged. So this will be the same as 4x plus 5 over x minus 3 minus 2x minus 3 over x minus 3. Because we changed these signs, we can change these signs. Okay, now we're just adding through. So we have 4x plus 5. We're going to distribute the negative here. So that'll be minus 2x plus 3 over x minus 3. And then we add the like things together and we get 2x plus 8 over x minus 3. Okay, now we're going to talk about 30-degree, 60-degree, and 90-degree triangles. Right triangles whose acute angles are 30 degrees and 60 degrees are often encountered in math and physics, or at least in their textbook examples. These triangles are all similar to this triangle. There's a nice example on page 279 of how this triangle was derived, but what you need to remember is all 30, 60, 90 triangles are similar to this. So the base is 1, this side is the square root of 3, and the hypotenuse is 2. Okay? So, here's our first example. Use similar triangles to find x and y. And here we have a 30, 60, 90 triangle whose hypotenuse is 5, the base is y, and the height is x. So, first we find the scale factor from right to left. assuming this little guy is on the right. This is 60, and this is the square root of 3. This is 1, and this is 2. So we're going to do this one first. So we have 2 times the scale factor equals 5. So the scale factor equals 5 halves. And now we can use the scale factor to find x and y. So to find x, we have the square root of 3 times the scale factor, which is 5 halves, will equal x. So x equals 5 times the square root of 3 over 2, right? And then to find y, we're going to do 1 times the scale factor equals y. Oh, yeah, and the square factor is 5 halves, so this is 5 halves equals y. Okay, that's not too hard. And that's it. So try the practice problems and let me know if you have any questions. Thanks!